to introduce our first speaker for today, and that's Joseph or Joe Curran, who is a fourth-year PhD candidate focusing and specializing in archaeology. His research uses interdisciplinary methodologies to operationalize post-colonial theoretical paradigms in examining how Indigenous people adapt, resist, or redefine colonial technology in the Southwest borderlands. He has recently published a co-authored article on, quote, war clubs in Southern California in the Journal of Archaeological Method and Theory, and he's also presented his research widely in many conferences. So please join me in welcoming Joe.
Hi, everyone. Let me get this up really quick. There we go. All right, thank you everyone for joining me today for this pro seminar. Before I begin, I would like to acknowledge that I am presenting from Henderson, Nevada, which is on the lands of the Southern Paiute people. Today, what I will be doing is presenting my research on the roles of technology in Indigenous negotiations and conflicts. Specifically, I apply an innovative methods to a case study examining how Indigenous people in the lower Colorado River Basin continued the use of their weapons in conflict negotiation despite the availability of colonial technology. There we go. So what I'm really trying to do here, and the crux of the problem, is I'm trying to refute assumptions and assertions of previous academic works in the region and previous academics, including archaeologists, anthropologists, and historians. A lot of these academics have assumed and asserted that Indigenous people rapidly adopted supposedly superior European technology, and that their technology was simple and inferior to this technology. And they also have assumed that the past is static and the Indigenous history remained unchanged throughout the period. So this has led to an erased history for Indigenous people. And so to confront this erasure, I am seeking to complexify the Indigenous colonial history of North America by looking at material culture to illustrate the nuance of negotiation and conflict. And I'm also trying to ascertain the usefulness of interdisciplinary methods in addressing these assumptions. And finally, I'm looking at how people negotiate change through adaptation, resistance, and/or redefinition of outsider technology. So I'll begin with an example of warfare in this region, conflict in this region, with the Battle of Maricopa Wells in 1857. In this battle, the Quechan Mohave group raided the Maricopa. In the resulting battle, it was fought on foot with clubs, or with traditional weaponry, including clubs. However, allies such as the Tohono and Apache did use horses and firearms, but these were only used to surround the battlefield and prevent the Mohave and Quechan from escaping. The resultant battle, which was fought slowly with indigenous weaponry, resulted in the devastation of the Mohave Quechan force almost to a man. So this leads to the essential question of why did the people of the lower Colorado River Basin continue to use the club in battle on foot when other neighboring groups such as the Apaches, Utes, and Comanches were adapting the horses' cavalry and using firearms and steel lances. So to answer this question, investigate the continued use of clubs, and revise the archaeological record of conflict in this region, I apply an interdisciplinary method that integrates archives and museum collections into archaeological and biomechanical engineering sciences. I use these methods to refute these assumptions and assertions that these indigenous technologies were simple and inferior to European weapons. And finally, I'm trying to understand the social significance of clubs and why they continue to be used. So here I have a basic typology that I created. On the left, you see we have the basic truncheon type. In the middle, and it's stick type club. And in the middle, we have a mallet and with a cylindrical head. And on the right, we have a ball club with a spherical head. So Kenneth Stewart, in his 1947 ethnographic description of Mohave warfare, describes the use of these clubs. To quote him, the club, which can refer to the mallet or also the ball club, was grasped near the cylinder rather than at the end of the handle, and it was usually smashed into the chin or face with an upward stroke. Occasionally, the warrior struck downward at the enemy's temple. A warrior might seize an enemy by the hair and club him, then throwing the foe over his shoulder to men armed with heavy straight clubs, or the truncheons, with which they cracked his skull. So to see if this is how the clubs were actually used, as described by Stewart, I created an innovative experimental archaeology and biomechanical engineering analysis that tests how lethal these clubs were, why certain regions of the skull were targeted, and how to recognize the resulting trauma from club blows to the cranium. So what we see in my results, we see here that average results from parietal testing on the parietal region of the average force are well within known fracture force studies. So here we have the two different ranges, and you see that most of these results are well within or even significantly higher than these ranges. Now, when we look at strikes to the frontal region, we see something that's a little bit different. We see almost the reverse, where we have strikes that are well outside of our known fracture force studies here, well within or on the cusp of causing fracture. So what these results tell us is that strikes to the side of the cranium likely cause complex trauma and could be lethal. However, strikes to the front of the cranium would cause no fracture or only simple trauma and were likely non-lethal. These results reflect what Stewart mentioned in his account and also what we see in the bioarchaeological record. What we see is people practicing face-to-face combat that is non-lethal and targets the face. And also lethal trauma in the bioarchaeological record is mostly on the parietal region. These results also indicate that this was a that these clubs were specialized weapons that are complex to manufacture and require great skill and immense training to wield properly. This evidence refutes assertions that indigenous weapons are simple and require little expertise to use. Now, what I'm currently doing is I'm looking at archival data to try and see how we can apply this to the case study of the Lower Colorado River Basin. And some of the sources I'm using are Spanish documents. So I'm using the Journal of Juan Baptista de Anza's 1773 expedition, where he tried to connect Sonora to the missions in California. And I'm also looking at diaries and maps of Fray Francisco Garces and Fray Pedro Font, who tried to establish a mission in the area. And also the documents of the Office of the Viceroy Bucareli Ursua, who was that detail the expulsion of the Spanish from the region from which they never returned. So this happened in like around 1778. And the next records we have of this region are Anglo-American documents from the mid-1800s, such as the one that I mentioned earlier that describes the Battle of Maricopa Wells. And these are from soldiers, sailors, and squatters. And these detail their overland journeys and conflicts with indigenous people in the area. What we see when we look at these documents is the pivotal change in relations in the Lower Colorado River Basin from the time of the Spanish invasions to those of Anglo-Americans. And we see that there was an alliance system that it developed and more endemic conflict that's more intense and possibly related to the slave trade that was going on between with the Spanish and trying to get labor for the mines in northern Sonora. From the documents, what I'm trying to do is infer what occurred beyond the scope of colonial records, what happened in this gap between the expulsion of the Spanish to the arrival of the United States into the area. And so we can try to understand changing alliances, enmities, territories, and migrations to and from the Colorado and Gila rivers. So this preliminary evidence points to that the peoples of the Lower Colorado River Basin resisted the use of firearms and continued using these clubs in formal battles and raids. And what seems to be apparent is that firearms, there may be a couple reasons. Maybe firearms were possibly too lethal and caused a shift in the balance of power, so they decided not to use them. Or also clubs are stealthy and really useful for grading, so they could have used them for that. What's also apparent in these records is that they redefined the horse for an inter-village warning system instead of using them as cavalry. So all taken all together, this evidence refutes assertions of that indigenous people in this region automatically adopted supposedly superior colonial technologies. However, a deeper investigation is needed and to fully explore the nuanced negotiations and conflicts and revise the archaeological record. And so that's what I'll be doing for my dissertation, hopefully with NSF funding, but we'll see. So if you want to contact me about any of this, here is my email. And if you want further reading about my methodology or anything else relating to this study, this is the reference for my, my new article. Thank you, everybody.
All right, so now we're going to welcome Daniel Perez. I'm going to introduce him very briefly here. Daniel is a fifth-year doctoral candidate working with Dr. Curran Harry on the archaeology of the Virgin Branch region of the North American Southwest. His dissertation research at UNLV focuses on understanding Virgin Branch group identity through stylistic design analysis on pottery over time. He's also published on use-wear analysis on monos or grinding stones from the nearby Shivwitz Plateau in the Nevada Archaeologist, and he's also published on the results of the excavations of an Iron Age site in the state of Israel. So really a broad span here. He's also finally, he's the author of numerous technical reports on the archaeology of Iron County, Utah, and the recipient of numerous awards and fellowships from our university. So please join me in welcoming Daniel.
Great, thank you so much. So the research I'll be presenting on today relates, I guess, tangentially in a way to my dissertation research, but is really a separate project unto itself. And I'll be talking about the notion of chronology and chronometry in the Virgin Branch region, specifically from the lens or perspective of Southern Nevada. So this map here shows the entirety of the Virgin Branch region. The Virgin Branch region spans essentially southern Utah, northwestern Arizona, and southern Nevada, with a lot of research in recent years being conducted on the Shivwitz Plateau by my advisor, Curran Hari, and other projects on the Uinkaret Plateau as well, with other researchers working there. But the research today that I'll be talking about centers on the in the Mohave Valley near Overton, just northeast of Las Vegas here. And I'll be talking about two sites in particular as a case study for better understanding and refining the Virgin Branch chronology as a whole. So the first site here is House 47. This was a site that was first explored in the early 20th century by Mark Raymond Harrington and subsequently followed up by Richard Schuttler for his dissertation work. And this is a site that is made up of numerous rooms and compartments that is one of the most complex of this time period. We're talking essentially at the peak of social and population aggregation in the Virgin region in the Pueblo II period, or really the late Pueblo II period. And this is a photograph here from that time period to give you an illustration of how that looked before the flooding of Lake Mead and then the subsequent excavations that have taken place since then, which I'll touch on in a moment. And then the other site that I'll be focusing on was identified in a pedestrian survey just north of House 47. And this is, again, near both of them are near Overton, Nevada. And this is part of the Muddy River Survey, Site 59, in which this was identified in a survey by UNLV's Claude Warren, and then followed up on by different researchers for dissertations and other articles and other projects in general. So this was not an actual excavation-based project, but a survey-based project. Since the excavations at House 47, my advisor Karen Hari conducted excavations there in recent years with students, and came away with numerous findings, which I won't touch on here, but just to illustrate that there have been more findings from House 47 since the early 20th century. So the main focus here of this talk is the chronological considerations in the Virgin Branch region. And to consider chronology in the Virgin Branch region, there's been generally a few approaches that have been consistently applied. The first of which has been to use painted ceramic design styles as rough analogs, painted design styles from the neighboring Kayenta region in northeastern Arizona, as approximations of when certain stylistic designs were introduced, and thereby giving us an understanding of chronometric or temporal control in the archaeological record. A second approach has been the use of proportions of corrugated ceramics. This was used, for instance, from the Muddy River survey sites, the many different sites that were explored there. And essentially, different percentages of proportions of corrugated pottery within a given assemblage essentially approximate and give relatively accurate information as to the temporal archaeological period that we're talking about. It doesn't give us a fine-tuned chronometric date with the given date, such as radiocarbon dating, but it gives us a rough idea of what we're talking about in terms of the span of time in late prehistory in southern Nevada. And then finally, there's been use of radiocarbon dates. And so this is charcoal seeds and many other forms of organic materials that provide a bit more refined chronometric control in terms of what we're talking about. The sort of poster child and sort of the reference point for this research was essentially me looking at northeastern Arizona in the Kayenta region at the well-dated sites of Batatican and Keith Seal. Really not arguably, they are essentially, at least with Batatican, is the most well-dated prehistoric site in the world, given the fine chronometric control that was established and obtained through tree ring research by Jeff Dean and others at the University of Arizona. And so this sort of reference point is something that is something to aspire to, but I'm under no illusion that one can necessarily get to that level of precision and refined chronometry without all those variables such as tree ring dates and so forth. So to approach this, instead of tree ring dating or dendrochronology, I sought to pursue this through OSL dating or optically stimulated luminescence dating as a reference point for understanding an actual event in the archaeological record. In this case, namely a firing or pottery production, whereas that would give us a time from which a site was occupied, or at the very least, the last time a given pot was fired to a sufficiently high temperature. And this is a dating method that is still being developed, but has been widely used around the world for a means of chronometric control in the archaeological record. So the primary research objectives that I had were essentially twofold. Quite simply, one was to obtain dates through OSL dating from these two sites of House 47 and Muddy River Survey Site 59, and then reassess this dating sequence through a sampling of 12 OSL dates, 12 different sherds of different types and painted designs and so forth from both these sites as a whole, 6 from each site, as a means of better understanding the temporal sequence and dating sequence for the Virgin Branch region as a whole. So the OSL dates from House 47, displayed here on this graph, show the date in red with the red line in each of those gray rectangular boxes, and then gives us the time, the range, the error, the plus and minus in terms of number of years, giving us the overall time scale for each of these dates. And the vertical alignment of the different periods of Basket Maker 3, Pueblo 1, early Pueblo 2, etc., correspond to the line graph at the bottom in terms of where this falls with the Kayenta chronometry that we know is well established in northeastern Arizona. So in between those two is where we see these gray boxes, where we actually see corrugated ceramic, plain ceramics, and even painted ceramics terms of where they fall in the overall alignment based upon these specific dates from House 47. Similarly, from Muddy River Surveys 59, we find a similar display of dates sort of spanning the entire gamut, in some cases going beyond the late Pueblo III period, which I'll talk about in a little bit. But we see again this comparison between these two, the Kayenta chronometry at the top with the actual name designations, and then the bars of what these OSL dates are giving us for the Virgin region in southern Nevada specifically. Taking as a whole, these are both of those sites combined into one graph. And we see that a couple of interesting observations that I'd like to highlight from this research project. One is that there's a clustering of dates here at the end, what would be thought of as the end or the late portion of the occupation sequence for both sites, which is very interesting. And there's some implications for that, which I'll touch on in the next slide. And this is a combination of corrugated and plain as well as painted ceramic. So it's not just one type of ceramic. And then also there's an interesting finding of Chivwitz Plain, which is a pottery type that was produced on the Chivwitz Plateau, which is actually found to be very late in the sequence here in this from this given date from that particular Chivwitz Plain sherd, which I'll touch on the implications here in a second. So the overall implications of these dates from the Mapa Valley specifically are really four parts. One is that this seems to change the occupation of site duration that's previously been reported, expanding the occupation phases beyond typically one period, such as Pueblo III period, and expanding that beyond, as well as challenging the notion of the deep depopulation episodes in the Mapa Valley as being around AD 1150, but rather potentially even later. Presenting with the Chivwitz Ware sherd the idea of trade extending beyond the Middle Pueblo II period between the Colorado Plateau and the Mapa Valley, and also potentially giving sort of voice to a rather minority position of contemporaneous occupation between Paiute populations and Virgin Branch peoples at the end of that sequence. And then finally, one final point here to state is that the overall thrust of this is to, again, get at the idea of trying to specify a target event in the archaeological record as opposed to relative dating methods to serve as an analogy or an analogous function to that of what we see in tree ring dating in the Kayenta region. With more ceramic dating samples and specimen through OSL dating and other dating methods, we can hope to refine this chronometry more and more over time to the perhaps resolution that we can get at some Kayenta sites. And some more additional testing will include statistical error testing and interval testing, as well as reassessing confidence intervals with these OSL dates accordingly. So thank you very much.
Thank you for the day is Dylan Person. Dylan, if you could. All right, great. And so Dylan is a PhD candidate as well. He studies archaeological sites in southwestern New Mexico. He is interested in understanding the interrelationships between artifacts, technologies, and human behavior. He's working with Dr. Barbara Roth to understand the relationship of these technological systems and social life at sites in the Mimbres Mogollon region that were active between AD 550 and 1130. Aside from his work in New Mexico, Dylan is also a graduate assistant at the Desert Research Institute, where he works in cultural resource management for nuclear testing related activities on the Nevada National Security Site, and he's actually authored many technical reports to this end. So please join me in welcoming Dylan.
Everybody hear me okay? Okay, good. All right, let's go. So hello, everybody, and thank you, Alan, for the introduction. I maybe sound pretty good. That's always nice. So to jump right in, my research focuses on two things: stone tool or lithic artifacts, and the relationship between humans, artifacts, technological systems, and just kind of the objects created by these systems, in my case, artifacts. As we've mentioned, my work is based in southwestern New Mexico, specifically in the Members Valley, shown here, an area in the mountains that contains the Members River, along which are numerous related archaeological sites. My research at UNLV has largely consisted of artifact analysis of collections recovered from excavations by our own Dr. Barbara Roth, whose work at UNLV has focused on investigating and understanding these sites as they went through a period of major changes in their subsistence strategy, residential mobility, social organization, and religious expression. So one of my favorite quotes about lithics is from James Sackett, where he described lithic artifacts as silent, modest, and alien. And what he meant by this is that they are made of a material that endures throughout time in the archaeological record, but does not lend itself well to decoration, stylistic modification, or other types of markers we use to infer cultural meaning and social affiliation. So we have to work around this limitation to apply more complex theoretical perspectives to these artifacts. To accomplish this, my research design draws from the anthropology of technology by using the concepts of chaîne opératoire, technological styles, and the transmission of these styles through communities of practice. Chaîne opératoire refers to the total technological process of creating an artifact, from raw material acquisition to artifact discard. Technological style is a specific process within chaîne opératoire chosen to achieve a technological goal. Since there are many ways to achieve similar technological end products, or artifacts, I see evidence for technological styles as a way to infer the presence of communities of practice, or social groups focused on teaching and learning. Communities of practice enculturate new members as part of the teaching and learning process, while drawing their values and rules from broader social contexts. Importantly, from this, they develop their own group identity and structure that is passed down alongside technological styles. Since making lithic tools required training, associated with this had to be a learning framework designed to pass this knowledge down. Both archaeological research and the limited ethnographic evidence available on lithic reductions suggest that this process was practiced in a social context. Following this, I take the process of learning a lithic technological style as taking place in a community of practice. This view connects material objects to social process and facilitates establishing archaeological correlates to provide support for inferences regarding the type of groups that made and used lithic artifacts at my case study sites. To investigate this, I study debitage, or expediently produced stone tools and rock debris that resulted from lithic reduction. Rocks that have a high silica content, such as chert, obsidian, or certain other igneous rocks, fracture like glass when struck with another stone. This causes the rock to fracture predictably and results in a sharp-edged stone flake detaching from the parent rock. From this, these lithic cores can be worked into a variety of tool forms by reducing material in this way, the most recognizable tool usually being the projectile point. But in contrast to a formal tool, such as a projectile point or some sort of processing tool, an expedient tool is simply a stone flake that can be used as a cutting implement, or serve as a source for further reduction to smaller flakes. Debris is exactly what it sounds like: angular rock shatter that occurs from material flaws, technical error, or just randomly during the reduction process. Though both are classified as debitage, my primary interest is in studying lithic flake morphology, since flakes are tools themselves as well as representations of steps along a technological continuum. However, debris provides information on material choices, skill levels, and degrees of on-site lithic reduction, so it is not unimportant. So not only do lithic artifacts have a potential time depth of thousands of years of de facto preservation, debitage in particular is very abundant in archaeological assemblages. At this point, I believe I've looked at almost 30,000 pieces of debitage, so I can safely say that I have a fairly developed sense of what was going on with this technological system and the artifacts that it produced. So despite being somewhat difficult to derive social meaning from, I have a lot to work with when it comes to sampling, statistics, and just generally figuring out what was going on with these artifacts at my case study sites. Now, what am I doing with all this? I'm using lithic and other archaeological data to infer the chaîne opératoire process practiced in the Members area. Drawing from this, I am further analyzing these data to support my argument that certain patterns derived using statistical tests, analysis data, and archaeological correlates from my case study reflect technological styles. Since different technological styles can result in similar artifacts, delimiting these styles removes some homogeneity from debitage, making it easier to correlate with other aspects of the archaeological record and produce more refined inferences from these data. Currently, I'm focusing on defining technological styles using intrasite, intersite, and regional scales of analysis to determine the number and extent of lithic reduction methods at my case study sites. After completing artifact analysis, I will compile data on individual houses, corporate groups, and site-level scales to support a reconstruction of their chaîne opératoire. I will use statistical techniques, comparative analysis, and archaeological correlates to find data patterns to determine technological styles and the archaeological visibility of communities of practice that I have inferred at my case study sites. I will then correlate these data with existing knowledge about these sites, as well as supportable examples from ethnographic analogy. I have created, to this end, I have created 3 models of archaeological inference for use in my research. The first correlates technological styles with household units and social groups. The second considers multiple technological styles as present, but not connected to social units, and thus examines gender, kinship, and other aspects of identity that we see in the archaeological record. The third model views technological style as a regional phenomenon and uses the anthropology of technology theory to examine how a single general style was present over a large region with many instances of variability in other types of material culture. So to use this information, I have selected 3 member sites for my case study: the Harris site, the Elk Ridge site, and the La Gila Encantada site. Harris and Elk Ridge are in the Members Valley itself, while La Gila Encantada is outside the valley and to the west. Though despite this is definitely a member site. All these sites were active during the late Pit House period, and Elk Ridge had a major Members Classic component. These spatial and chronological contexts allow me to view technological differences and similarities over time and space that support and broaden interpretations I draw from archaeological data. The Harris site was a sedentary agricultural village, most active towards the end of the Pit House period. Investigation into its archaeological record has shown evidence for related household groups, which have been inferred as corporate groups. These corporate groups represented a change from earlier social organizations that centered on individual households, a change that persisted into the Members Classic period in the region. Additionally, mortuary data has shown evidence for incipient degrees of social status and the practice of social memory through burial placement, as well as archaeological continuity between construction phases in the houses. Strangely, Harris was abandoned at the end of the late Pit House period, unlike other major Members Pit House sites that continued their occupation into the subsequent period. Elk Ridge was another agricultural site at the north end of the Members Valley that was populated during both the late Pit House and Members Classic periods. As such, it has pit houses as well as later above-ground masonry pueblo structures. It exhibited a high degree of archaeological variability, along with the artifactual evidence of contacts with other Mogollon regions. This makes it a compelling site to examine for the evidence of different technological styles, as well as how lithic use changed at member sites as they became more populous, diverse, and agriculturally reliant over time. The La Gila Encantada site was a regional variant of the Members where people continued mobility patterns that were similar to earlier periods, shown by their continued focus on wild resources and foraging. However, they also followed the trend of agricultural investment and population increase seen at other Members sites, but at a lesser scale. Unlike the Members Valley sites, these people retained a social organization that centered on individual households, rather than adopting the corporate strategy seen at the larger Members sites. Whichever of my models fits best, I expect my research to produce new information about how people made and used lithics in the Members Mogollon region. Further, moving away from highly functionalist lithic perspectives provides insights into the relationship between these people and their technology. Since debitage has been understudied over the past 20 years, I see applying these newer theoretical perspectives as having significant value for archaeological practice, and hopefully will create new methodological direction for the many debitage artifacts stored in archaeological collections. And finally, from a personal viewpoint, it is very rewarding to be able to add a greater cultural dimension to these artifacts so that they are no longer so silent, modest, and alien. So to end, I'd like to thank Barb, Curran, and Yuman for being on my dissertation committee and helping me out with the many moving parts involved in my research. I'd also like to thank Liam and Alan for inviting me to give this talk, and Alan specifically is for managing our presentations. And finally, I'd like to thank my colleagues at UNLV and abroad, my fellow presenters, and you, the audience, for lending me your ear for this presentation.